Hello, welcome to the UNL School of Computing, Arman Roohi, FPGA Machine Learning Senior Design 2023 to 2022 to 2023 presentation. Today I'm going to be showing off everything we've done over the past 9 months, what happened, and just give you a general overview of everything. How do we go to the next slide?
Oh, yep.
Okay. All right. So for our company, the UNL Idea Lab is an exciting place. It's where the latest research and technology in software and hardware engineering converges, and we develop a more efficient and high-performance computer architecture design. Dr. Arman Roohi directs the Idea Lab, and he is the main sponsor of this project that we decided to work on. And he wanted us to develop a framework to work on FPGA boards that allowed the Idea Lab to analyze the security issues of quantized neural networks. Next slide. Yeah.
And this is Dr. Arman Roohi, a School of Computing professor. We have him here today. Thank you for being here. And he is our main stakeholder, and he owns this product. So moving on with our team, we have our product owner, Arman Roohi, as I just mentioned. Brady Garvin is our tribe lead, Melanie Kugler-Wright, project manager, and Nate Bennis is our industry coach. He actually works here at UNL. He's a great guy. As for the students in this project, we have Jacob Daffer, which is our squad lead and product manager. Aaron Linnell is our development manager. Anthony Liu is a developer. I am a developer, and Robert is a developer.
All right, so the main problem and the opportunity we had out of it for this project is Arman wanted us to have a live inferencing camera that could analyze the security issues of a machine learning model in an FPGA board, which basically just meant we could take a camera, connect it to an FPGA board, show it some images, or show it like a live object, such as like a bird or whatever, and it will be able to identify whatever is in front of it correctly and efficiently. And so we decided to simulate some forms of attacks as well to mimic a security risk. As well as implement some of the defensive measures against the security risks in our own code, so we both attack and defend our own program. And yeah, that was our idea that we had for an overall problem.
We had two types of attacks for this. We had adversarial, which is an attack on the input data of a model. This is done by putting a filter or any perturbation on an input image. As you can see, we have a picture of a panda here, and with some noise or some discoloration, really anything can trick the computer into thinking it's something else, like this is a parakeet, which obviously it's not. And we can see that, but it's just enough to confuse the computer. This is mainly done just to destroy the accuracy of neural networks and make it miscalculate things, and then you get a bad accuracy. Another attack we have is the bit flip attack. This attack is done on the actual weights of the model, going in and flipping literal bits. So you're doing an XOR operation, changes a 1 to a 0, 0 to a 1. And if you have a high significance bit, where it could be a high value, if we have 8 bits, that value would be 128. And if you flip that completely, then you have a negative value if it's signed. I'm getting into the weeds here. Basically, what's going on is you are destroying the accuracy of the model by flipping bits. An image can come in, any image, a panda that's unperturbed, no problems with the input image, and then the model will think it's a parakeet because of the bit flips that are going on, and that can be very destructive to the model.
All right, so in the solution that we built 2 separate machine learning models to analyze these images, inform their, identify their contents. We made separate models for both an adversarial attack and a bit flip attack, as well as for the defenses built in against them. And so for the adversarial models, we decided to use a data set of birds and classification of birds just as a base data set, but it can take any 220 by 220 image and take it as input. If you trained it on a data set, you could train it on anything, but we mainly trained on birds because there are a lot of them. They're very easily identifiable, and it's very easy to tell when an image of a bird is distorted just through the grain. We had 450 classes of them, and so it was very diverse. For our bit flip model, we used an SVHN dataset, which is essentially just some pictures of addresses, and it would identify a number of 0 through 9, whatever the camera was focused on in the middle. So you can see on our image here on our dashboard, it's like we have a camera focusing on the 6 of an address, and it is it's a little small to see here, but its prediction at the bottom is 6, and so it's accurately identifying and inferencing them. And another part of the solution is we built a dashboard, like as you see here, That allows us to toggle through different adversarial attacks or bit flip attacks. It goes to the FPGA board, and our camera module by default performs live inferencing, so you just get live video, and it'll change the prediction as the image changes, if it does change at all.
All right, so we have two solutions, one for both the adversarial and bit flip. So the image here is showing what putting distortion on an image will do to it. Obviously here we went from having a high accuracy to a very low, like 0% accuracy here. And for adversarial, we developed a model, a teacher and a student model. The teacher just goes through normal training and then teaches a student model who goes through training with normal images and adversarially attacked images. So when then you put an adversarially attacked image through the model, it's able to see right through the attack vector and correctly inference the image. For bit flip, we implemented something called triple redundancy module, or TRM. Basically what this is in our model, our most susceptible layer that could be attacked was the last output layer, right before the layer that actually outputs the value that its prediction is. And we take that, we multiply it by 3, or that's the number here we want. You can go n amount of numbers greater than 2. And basically, so what it is now you have 3 output layers. So instead of piping into 1, there's your output, you pipe into 3. And then after this, they vote on whichever number for SVHN they think it is, and then that is your output. So based on that, you can have 3 layers. If you have 1 attacked, you still have 2 making a correct inference. So then from that, you still have the right number. So then, best case scenario, the attacker's only able to target 1 out of 3 of the layers, and then you still have an accurate representation of your output value.
All right, so for the main value and highlights of this project, with our project, Arman and the Idea Lab will now be able to correctly analyze the security issues of quantized neural networks on FPGA boards. We think that we were very successful in the project and getting what he wanted so that the Idea Lab could properly analyze it. And as for the team, we learned a lot of good lessons ourselves on the side of it, beyond all the technical aspects of like machine learning, adversarial attacks, bit flip attacks, gradient masking, and so on. The list goes on and on and on. Some non-technical things that we learned how to properly assess and adjust the scope of a project in case it's like too large or too small. We can add or to take away from it. Figured out how to work on like a large project, like basically from scratch, and the importance of deadlines and setting deadlines to it. So that was a great lessons that we learned. Yeah. Thank you guys very much for this project. It was very cool, very awesome.
We do have a shout out to the National Research Laboratory, who was generous enough to allow us to use a bunch of their GPUs for our training. We used a lot of their resources, and which was very helpful to us. If we didn't have all of their stuff, our 13-hour training process could have taken several days. So we are very happy that they were allowing us their
And we do
resources.
have something for you, Arman. If you'd like to come up, we have nice
Yep,
little
we have an award for you, Arman. Here's your award for being our
Thank you.
sponsor this year.